Okay, so this is a titration problem. So it says initially you have 25 milliliter and 0.09 moles of the acetic acid. And now you add about 20 milliliters of the zero point 0.1 moles of the sodium hydroxide. So now we want to know the pH. The first step, we need to find out the initial moles of the acid and base. So initially, the moles of the acetic acid equals to the concentration times the volume. So that's about 0.09 times 25 over 1000. So that's about 2.25 times 10 to minus 3 more. And then if we calculate the moles of sodium hydroxide that we used for the titration, it's equal to 0.1 times 20 over 1000. So that's about 2 times 10 to minus 3 more. And looking at here, you'll find that after the titration, there's still some acid left. So, right, if we write down the equation, you'll find its sodium hydroxide react with acetic acid, right? The reaction ratio is 1 to 1. So in the initial condition, right, you have more acetic acid react with sodium hydroxide. So there would be acetic acid left. So in this case, we know the reaction, right, all the sodium hydroxide will be reacted and will produce the acetic acetate, right, sodium acetate. So first, what we can calculate is the moles of the sodium acetate here. That's equal to the moles of the sodium hydroxide. So it's about 2 times 10 to minus 3 more. And of course, the left amount, right, the change, the left amount of the acetic acid is equal to the initial amount of the acetic acid minus the moles of the sodium hydroxide. So it becomes about 2.25 minus 2, right, times 10 to minus 3 more. So that's about 0.25 times 10 to minus 3 more. So let's look at this. You'll find in this solution, right, there's a coexistence of the acetic acid and sodium acetate. So the sodium acetate is a conjugate base and acetic acid is a conjugate acid. So now the final solution will be a buffer. So then the pH of the buffer equals to the pKa of the conjugate acid minus log the concentration of the conjugate acid, right, over the concentration of the conjugate base. So in here, let's just plug in, right, pKa, it's minus log Ka. The Ka value is given 1.75 times 10 to minus 5 and minus log. So the concentration ratio, right, should be equal to the mole ratio because it's a mixture solution. So the acetic acid here, right, the conjugate acid is acetic acid. So it's 0.25 times 10 to minus 3 over, in this case, the base, right? It's about 2 times 10 to minus 3. So that's equal to 4.76 minus minus here is about minus 0.90. So now it becomes about 5.66. So the final answer is 5.66. That's it.